so we should be able to finish in this video. So I've got a better guess for my Reynolds number now, based on a better guess of diameter. What are we trying to do? Well, again, I've got a better guess for diameter. Now I've got a better guess for Reynolds number. Let's get a better guess for my friction factor. So we found the friction factor and my Reynolds number of, it's going to be 9.4 times 10 to the 4 is my new Reynolds number. Epsilon over D is still equal to 0. That's going to give me a better value for F. Let's do that here. Let's see if I can do this with a different ink color, so maybe we can see that better now. So ink color, let's do a green. My Reynolds number now is going to be, it's not going to change much. We're real close to about there. All right, we're real close to this 10 to the 5. Not quite there, but real close. And so I might be able to move over just a little bit. And I could say my friction factor is going to be a little closer to just a little less than 0.019. So look on your Moody diagram, see what you get there, where 9.4 times 10 to the 4 intersects an epsilon over D of 0. You should be doing this along in your own Moody diagram. Okay. So that's going to give me a friction factor, we're saying there, of about 0.018. I'm going to say 185. Okay. Now, so all I'm going to do is I'm going to go back through this equation here, but the only thing that's going to change is this friction factor, right? Because we can find, based on the head loss and the new friction factor, I can find the diameter here. So if you already got this in your calculator, just go second entry and change this number, and that'll spit out a new value there. Now I'm using an old-fashioned calculator app on mine. I should probably try to go find a better one for doing this. But anyway, so I'll do it hardcore here. That's going to be, so again, I'm going to take 8 times, now my new value for F is 0.0185. And the others are going to stay the same, times 400 times 12 divided by gravity is 32.2 divided by pi is going to get squared and divided by 50. And I'm going to take the 5th root of that. I missed it. It should not be that different. Hang on. I'm going to take 8 times 0.0185 times 400 times, I didn't square the 12. 12 gets squared. Divided by 32.2 divided by pi squared divided by 50. There. Now how did I know I messed it up? Well, because I should very quickly start getting a very similar value here. So when I didn't square the 12, I got a very significantly different value, and that tells me, you know what, try it one more time. Maybe I punched something in the calculator wrong, or I missed a value. You should very quickly start getting the same set of values for the diameter. So this gives me a diameter of 0.883 feet. Okay? Now, I could probably quit there, honestly, because I've got the same first significant figure between my previous first guess. I've got a change in my second. Now, anytime your second significant figure changes, that tells you, you know what, try it one more time. Given this diameter now, all right, let's go back through my loop. Let's find new Reynolds number, find new F value, and see if it gives me a different diameter. So, at a diameter of 0.883 feet, let's see what my Reynolds number would be. Reynolds number, I said just a second ago, it's going to be 84,540.7 divided by 0.883. I don't think I'm going to get much different. I'm going to get a Reynolds number there of 95 1,743, which is, we're going to say about 9.5 times 10 to the 4. And guys, I don't think with the Reynolds number or with the Moody diagram I can do any better, right? Because last time I said, well, I'm basically real close to the same green line I had earlier. I'm going to end up with very much the same F value there. Right? So with an epsilon over D equals 0, that's going to give me essentially the same F of about 0.0185, which we've already found D is going to be about 0.88 feet. Now, I'm not going to do it, but if we go back, this is page 7. Okay. So remember, we said on page 6 here, we started with a guess of 1 foot. Now, what I would suggest to you is if you started out with a guess of 200-foot diameter, which is ridiculous, you're not going to have a 200-foot diameter pipe, I don't think, for moving a small volume of air. But even if you started with 200 foot as your first guess of diameter, you'd still get a Reynolds number probably about 100,000. And 100,000 Reynolds number is still going to get you real close to an F value of about 0.02, 0.02. I don't know. It's going to get you, if you went back through, you'd find your friction factor is not going to be a huge difference. You run back through the same process where you just change this F value, you're still going to get about 0.9 feet first time back through. And you see very quickly, once I get to about 0.9 feet, then I'm going to get very close. So basically the first time through, you're going to get the first significant figure. Even if your first guess is garbage, you'll get the first significant figure here, and then run back through the loop another time to really hone in on the second significant figure. Now, if you use the Colebrook equation, you could get to the third significant figure of the F value, but really I've only got 2 significant figures here on my F value, maybe 3. So that's the reason I'm saying let's just assume 2 significant figures in my final answer. And that's probably the best we're going to do with just a simple Moody diagram. All right, hopefully this gets you started on your homework. It's a nice couple of example problems for today's lecture, and that's a good solid. I'm going to lose my voice if I'm not careful, so I'm going to stop there.